Hey, one and all, how are you doing today? Hope you enjoyed the first day of class, whether or not you were online or in class. But now you guys are all at a distance, or you're all in the same boat together a little bit. Yesterday in class, we dealt with the Earth's rotation, which is it's spinning about its axis. Okay, and we learned that that is what causes day and night. Now, those of you who were in class yesterday will learn a little bit more about that tomorrow. Those of you who are out of class, distance learning yesterday, will learn more about that again in class tomorrow. Today we're going to go a little bit different direction. Instead of talking about the Earth's rotation, we're going to start talking about the Earth's revolution here. Okay, and that's going to be what we're going to be focusing on. Just as rotation caused day and night, it is the Earth's revolution which is going to cause our year and the seasons here. Okay, so that's what we're going to be looking at today. So let's move ahead here and get to the next page. And we're going to spend a little bit of time on this page here. Let me just kind of move about here a little bit. There we go. And we're going to add quite a few things to this page. If you would like, you could pull out a notebook, and this will help you understand this idea a little bit better. So I'm going to give you a couple seconds. You pull out your notebook. I'm going to pause the video a couple seconds so you have a chance to do that. Hopefully you pause the video as well. So here, this is not drawn to scale, obviously. We've got this very happy sun. We're happy to have you back in school here. So we've got a happy sun. And this sun is about 100 times too small for this image. So instead of the Earth's rotation would be its spinning about its axis here. So that would be this type of motion, spinning about the axis. We're not going to be concerned with that so much as the Earth's revolution. And the Earth's revolution is going to be its motion around the sun here. Okay? And that action right there takes about 1 year. Okay? That's where we get that value from. So in this time that it takes to travel around the sun, the Earth is going to undergo a little bit more than 365 rotations. So one revolution is going to equal a little bit more than 365 rotations. And if you recall, we've got a couple ideas here that we want to bring forth again. So this imaginary line right here, we're going to call that the axis. And the Earth's axis is tilted at about 23.5 degrees from straight up and down. So this angle right here is 23.5 degrees from straight up and down. And that right there, you'll notice that it's always pointed the same direction. So this north axis here is always pointed the same direction. That is not going to change throughout the year. It's not like the Earth wobbles on its axis, at least over the course of 1 year. We're going to learn later in the year that over long periods of time it might do that. But for 1 year, we're not going to think that it wobbles that much. So it's always going to be pointed the same direction. Now, what does this mean? It means that at certain times of the year, okay, and let me see if I can do this. This might work a little bit better. Certain times of the year, this sunlight, these rays from the sun, are going to be more directed at the northern hemisphere. Whereas other times of the year, these rays of the sun are going to be more directed at the southern hemisphere. They're going to be striking the Earth more at an angle in the northern hemisphere. Now, it's not the distance from the sun that's going to be causing our seasons. It's this tilt of the Earth's axis. Now, this dashed line you see here is the Earth's equator. So we've got the northern hemisphere, the southern hemisphere, and the equator. And we're going to label each of these seasons here as we do this. So this season right here that we see over here where it's tipped to the northern hemisphere, that is going to represent the first day of summer. And we're going to call that the summer solstice. And the word solstice literally means sun stopping. Now, the first day of summer is usually about June 21st or so, okay? And that's going to be when the sun's rays are most direct over the northern hemisphere, and it's actually going to be directly over a line that we would call the Tropic of Cancer on that day, which is about 23.5 degrees north, okay? and that would be where the sun's rays would be immediately overhead at noon on that day. So let's say we keep following this throughout the season here, and we go from the summer solstice, and we're going to undergo about 90 rotations, about one season here. And on this day, this is going to be the first day of fall. And on this day, the sun's rays are going to be most direct right over, it's tough to tell from this angle here, but right over the equator. And this is a day that we are going to describe as being the, right here, I'm going to type it right here, that's going to be the fall equinox. And hidden in this word equinox are actually two words. Equa, which basically means equal, and nox is an old Latin term for night. So this means equal night. On this day of the year, when the sun's rays are most direct over the equator at noon, all the earth, doesn't matter where you live, you could live in Key West, you could live in Minneapolis, you could live in Sydney, Australia. All parts of Earth are going to get 12 hours of daylight and 12 hours of nighttime on this day. So let's keep rotating through the year here. Let's go here and let's kind of keep moving through the year. The Earth is going to rotate about another 91 days or so. And now we're going to get to what we are going to describe as being the winter solstice. On this day, let's type it over here. On this day, the sun's rays are going to be most direct over the southernmost part that it's going to be throughout the year. So the sun's rays are going to actually be most direct at a point 23.5 degrees south of the equator, and that's going to be called the Tropic of Capricorn. Okay, I'm probably off a little bit about where that is. Let's see if we can move this up a little bit here. It's probably about right there. That's where the sun's rays are going to be most direct. This ends up being the shortest amount of daylight for us here in the northern hemisphere. And this occurs about December 22nd or so. This occurs around September 22nd or so, the fall equinox. So that's our winter solstice. Let's keep going. Let's go another 91 days or so here. The Earth's going to rotate 91 more times before it gets here. Notice the tilt of the axis is always pointed the same direction, which is why you can always look at the North Star. The North Star is always up this direction, so that's where the northern axis of the Earth's tilt is always pointed. So this right here is going to actually represent the spring equinox. So I'm going to type this over here. Again, this is similar to the fall equinox in the sense that the sun's rays are most direct right over the equator again, and we will again have equal amounts of daylight and nighttime on this day. And finally, once we go from spring, this is going to occur about March 20th or so, and we're going to rotate about another 91 days or so here, and we get back to the summer solstice again. So this is going to represent 1 year. This is why it's going to be warmer in the summer, because the sun's rays are more direct over the northern hemisphere. This is why it's colder in the winter, when the sun's rays are more direct over the southern hemisphere. So northern hemisphere, southern hemisphere. The Earth's revolution contrasts revolution, which is its orbit around the sun, with rotation, which is going to cause day and night. Now, I mentioned the fact that each season lasts about 91 days here. The actual amount of time it takes for the Earth to completely revolve around the sun is 365 days, 5 hours, 48 minutes, and 56 seconds. And it's awfully kind of inconvenient for us in some ways, the fact that the Earth's amount of rotations doesn't equal a perfect year, but we allow for that. When we have this spillover of 5 hours, 48 minutes, and 56 seconds, that ends up almost being exactly 1/4 of a day. And so what happens is just every 4 years we add an extra day to the calendar, and those are going to be our leap years. We add that extra day, and that's February 29th of each year. So what I'm going to ask you to do now is watch a couple of videos and try to read through a little bit of text on a website and answer the practice questions there. And then finally complete a Google form to show me that you've learned the material for today and submit that. And I hope you guys have a good day. It's good to see you. We'll look forward to seeing you again tomorrow. Please email me if you have any questions whatsoever. Thanks for your time.